This is the second lecture on the basics of the periodic table. In the first one, you got a brief history of Mendeleev, the person who published about this, and that's always nice to have a little historical viewpoint. The basics is basically going to be a vocabulary lesson, so you may want to make sure you have a piece of paper out and stop frequently to make sure you understand what each term means. And the first thing we have to do is decide what periodic means, or actually define what periodic. And periodicity is a cyclical pattern. Now, a cyclical pattern is different from a non-cyclical pattern. That's sort of obvious. What do we mean by a cyclical pattern? It's a pattern that has some interval of time or distance between it. For example, if you get magazines, Time magazine comes once a week, I believe on a Tuesday. Sports Illustrated shows up on Fridays every week. Sci-Fi Now is a monthly magazine. It shows up on the same day, the first Thursday or something like that of every month. And Skeptic magazine shows up every 3 months. This is why magazines are frequently called periodicals, because they arrive at the same day after a certain amount of time. It is a cyclical pattern. Newspapers, however, are not periodicals. Why? Because they get delivered every single day. There's no repeating pattern. It is a consistent pattern. The periodic table of the elements is called the periodic table because there are multiple repeating patterns within the elements. And you're going to spend several activities later in the section looking at some of these periodic functions and hopefully understanding why these periodic functions occur. And the main reason has to do with the electron configuration, because all chemistry takes place at the electrons. So the first thing I would need you to notice is that red line starting over on the right quarter that looks like a staircase that we're going to give the fancy name of staircase to. Every single element to the left of that staircase, including the 2 rows below the major periodic table, are called metals. Anything to the left of the staircase are metals, which makes everything to the right of the staircase a non-metal. So left of the staircase metals, right of the staircase nonmetals, and there are several elements right along the staircase that under the right circumstance will act as metals, and those are called metalloids. And the other thing you need to note here is hydrogen, though it's on the left side, is not a metal, it is a nonmetal. The next 2 definitions are period and group. A period on the periodic table is a row. There are 7 periods to the periodic table, cleverly labeled 1 through 7. A group are the columns. And there are multiple ways of labeling the columns. We're going to use the American method, which is to label the columns from left to right, from 1 to 18. Lower rows below don't get labeled with numbers. So there are 18 groups and 7 periods on the periodic table. And by the way, you'll sometimes see the word group interchanged with the word family. Several of the groups have names. Column 1, or group 1, excluding hydrogen, are known as the alkali metals. All those metals are chemically similar. They have similar reactions, similar reactivity, and actually if you go to the internet and look up alkali metals in Brainiac, there's a nice video to watch, but if you watch it, you have to come back and tell me what the problem with the video is. The second column, known as the alkali earth metals, still reactive but less reactive than the alkali metals. Then we jump over to column 17. Those are known as the halogens or the halides, and in column 18 we have the noble gases. The noble gases because they usually do not react with anything. They're like royalty. They won't mix with commoners. Several other definitions you need to know. The elements in groups 1, 2, 13, 14, 15, 16, 17, and 18 are frequently called the representative elements. Columns 3 through 12 are known as the transition metals. They're a little more complicated when it comes to valence electrons. Valence electrons. Valence electrons are the outermost electrons in the electron configuration, the highest primary energy level. And then you can notice several other things on the table. Periodic tables you have, elements which are gas at room temperature are in red, liquids are in blue, solids are black, and man-made elements are white with a black outline. Just as a reminder, for each of the boxes in the periodic table, a lot of information is on your periodic tables. In the upper left-hand corner, in blue, you have the atomic number, the number of protons, the number that defines what the element is. You then have the symbol for the element. Underneath that is the name. And then you have the average atomic mass, the weighted average of all of the naturally occurring isotopes below that in red. And over on the right-hand side, you see the electron configuration. You'll see the freezing point in Kelvin. Oh, by the way, the temperature in Kelvin is just the Celsius temperature plus 273. You then have the boiling point, something called the heat of fusion, the heat of vaporization, which we won't get to unless we get to thermodynamics, so don't worry about that. The oxidation states, don't worry about that. And last is the density in grams per milliliter, unless it's a gas, and then it's given in grams per liter. So the periodic table will turn out to be the absolute best cheat sheet that you have, but it's not really a cheat sheet because you're allowed to use it. So it's the best source of information in a chemistry room. So to review, something which is periodic is something that has a cyclical pattern. A group on the periodic table is a column. A period in the periodic table is a row. A metal is all elements to the left of the staircase. A non-metal are all elements to the right of the staircase. A metalloid are specific elements abutting the staircase, most notably, by the way, silicon, arsenic, and germanium. The representative elements are groups 1, 2, 13, 14, 15, 16, 17, and 18. And valence electrons are in an electron configuration are the electrons in the highest primary energy level. So that's a brief introduction to the vocabulary of the periodic table. The next video, which is not one of mine, so it will not be on DCAPS chemistry, once again goes over this vocabulary plus more of it. And then the final video will be on the relationship between electron configuration and positioning on the periodic table.